Thank you for the presentation. Good morning to everyone. My name is Yeray Castillo Campo, and I am a geologist at Envo-Geo and the Geological Survey Ireland. Before starting, let me remind you that there is an app that you can use to ask questions. Today, I am going to talk about confidence level on shorelines. Throughout this workshop, we have seen what shorelines are, the prediction of where the tidal waterline would be at a determined time. The shorelines are obtained from a waterline, which in turn are derived from a satellite image. There are 5 different shorelines that are extracted from each individual waterline. It is important to note that all shorelines are extracted through an automatic process and that they have not been post-processed yet. In the graph on the right, you can see a beach profile with the 5 reference datums that have been used to derive each of the different shorelines. HIT, or highest astronomical tide, which is the highest level that can be expected to occur under average meteorological conditions and under any combination of astronomical conditions. MSL, or mean sea level, which is the average observed height of the surface of the sea relative to a stated vertical datum, and LAT, or lowest astronomical tide, which is the lowest water level that can be expected to occur under average meteorological conditions and under any combination of astronomical cycle. While the image on the left corresponds to an orthophoto from 2014 on the Irish East Coast, in which the 5 shorelines have been superimposed. To understand a little better what the validation process has consisted of, I am going to focus on a specific study area, Portmarnock. For those who are not familiar with, Portmarnock is a coastal suburban settlement of Fingal County, located 15 kilometers north of Dublin and about 3 meters above sea level. With a length of 5 kilometers, there is a beach with a sand dune system south of Portmarnock, whose sea-facing side is known as Velvet Strand. The aim of the validation is to provide the user with a level of confidence in the components of the shoreline products based upon a series of indicators and tests. As we have seen in the previous presentation, the shorelines validation, as well as the waterlines validation, takes an internal quality control and external approach. Internal quality control analyzes the shoreline within the processor, while judging quality based upon the shoreline's own merits. External quality control is applied post-processor and judged quality based upon external products, such as other processed shorelines, orthophotos, co-registered images, or reference layers, like the sample shown here. Shorelines validation has been carried out by measuring the variation with the reference layers. In the image on the left, you can see a segment of the Portmarnock beach, approximately 1.5 kilometers long. 2 black lines appear superimposed. One of them, with a solid line, represents OSI high water mark, while the dashed line is another OSI high water mark. The comparison has been made in the transect indicated in red. Here, you can see the results obtained from comparing the HIT shoreline of 7th April 2020, represented by a purple line, with OSI. There is a difference of 29 meters, while the distance with the other OSI reference is just 25. Transect 2, the difference are reduced to 3 and 14 meters, respectively. This series of images, from left to right, represent a validation sequence in which reference data is A. Image A are 3 shorelines from the same year. Image B are these same 3 shorelines compared to the 2 OSI reference lines. It can be seen that there is a large overlap in the strait areas in general and a significant discrepancy in the curve of the beach. However, in image C, where all the layers of B are included in an orthophoto from 2014, greater similarities can be identified between the profile drawn by the shoreline in the curve area and the orthophoto. Once the methodology is presented, it is important to know the accuracy of the shorelines. In this case, 5 shorelines of the year 2019 have been compared. In the zone of the transit, one can see how all the shorelines are located between the two reference lines, despite showing differences between 18 and 37 meters for both reference layers. On the other hand, in transit 2, the divergences are considerably reduced, between 3 and 22 meters. The best results are obtained from the comparison with OSI high water mark, where the distance are within the pixel resolution, which is 10 meters. Shoreline validation versus vegetation lines. Vegetation line means the first line of stable natural vegetation, which shall be used as the reference point for measuring oceanfront setbacks. This line represents the boundary between the normal dry sand beach, which is subject to constant flux due to waves, tides, storms, and wind, and the more stable upland areas. It is generally located at or immediately oceanward of the seaward toe of the frontal dune or erosion escarpment, as you can see in the graph. Geological Survey Ireland has a series of vegetation lines from 1995 to 2020, being another data set of reference layer for the validation process. As you can see in the example, when comparing the vegetation lines of the years 2017 and 2018, represented by green lines, versus the shoreline of 2018, the blue line, differences are again obtained within the pixel resolution. Each shoreline is accompanied by its corresponding metadata file, where data such as general info, product name, product description, or product qualifier are included. Auxiliary data like water level and datum height are also, or ancillary data like shoreline slope buffer size, maximum joint length, or segment length, among others. We understand that all this data is of great value for end users, since it not only informs on the type of methodology that has been used to obtain the shorelines, but also in its possible applications and use. Here you can see an MSL, or mean sea level, shoreline, and the Sentinel-2 image that has been used to extract the original waterline from which the shoreline was calculated. The total number of shoreline is 1,760. 33% are from the Waterford area, 25% from Wexford, 23% from Cork, and 19% from Dublin. The images used correspond to the Sentinel-2, Landsat 8, and Landsat 5 missions, covering a total time range of more than 25 years from 1994 to 2020. Which are the future challenges? The next step will be to calculate the statistics automatically to obtain accuracy indices to the reference layer at regular intervals. It is also expected to implement the DISAS, Digital Shoreline Analysis System, toolbox to quantify and monitor shoreline rate of change statistics. I would like to finish with some key ideas. The number of shorelines totals is 1,760 spread over 4 steady areas: Dublin, Wexford, Waterford, and Cork, corresponding to a time range of more than 25 years from 2020 to 1994, and 3 different missions: Sentinel-2, Landsat 8, and Landsat 5. 5 shoreline products: high astronomical tide, mean high water spring, mean sea level, mean low water spring, and lowest astronomical tide, calculated for each waterline. Shorelines showed a general good agreement with reference layer, orthophotos, and in situ measurements. Our homework, or the future work, we will use this as toolbox to obtain accuracy indices to the reference layer at regular intervals, a key factor to estimate and diagnose the coastal dynamics. Thank you for your attention.